Assalamualaikum and hi everyone. This video is to show about the miracle of human engineering and connection, work in a demanding and dynamic environment where security and safety are the most important. This video will also explain the background of Cathay Pacific, 5 risk registers including bogus parts, fueling safety precaution, independent or duplicate inspection. We also have foreign object damage in terms of tools and also oxygen safety precaution. The last part of this video, we also talk about the method on how to reduce the risk. So let's move on to the topic.
So today I'd like to discuss about this bogus risk of bogus parts and approved parts install risk of installing onto the aircraft. Bogus parts are also called suspected and approved parts (SUPS). There were 3,000 suspected and approved parts fitted onto the aircraft since 2011, according to FAA. So bogus parts can be as identical as the original part approved by aviation industry, making it difficult to differentiate between fake and genuine spares. The reason for producing bogus parts are due to cost control pressures, profiteering, inadequate documentation without FAA or EASA certificates, complex supply chain, ineffective oversight and shortage supply of approved original equipment manufacturer OEM parts. Installation of and approved parts onto the aircraft is serious safety issues and it violates the rules and regulations set by local authority, and if left unchecked it affects the safety of the operation of aircraft system where these bogus parts are installed, and more importantly authorities can revoke the certificate of airworthiness and air operator certificate from airlines, resulting in suspension of airlines operation. The level of severity can be fatal to 18.5 because the fake parts do not go through certification process and the design cannot guarantee the safety why they will fail over time, affecting the operation system of the aircraft such as flight control system, hydraulic system, avionics system, and engines. The likelihood of incidents can be possibly reinforced since so many aircraft parts are withdrawn every day from the store to replace the defective ones on aircraft, and one of them could be bogus parts. So the mitigation measure of bogus parts. So in order to eliminate this risk of using or installation of bogus parts, administrative controls have to be put in place, such as ordering spares from approved and reputable suppliers, manufacturer. For example, supply chain need to be ordered directly for Boeing, Airbus, and Honeywell or other vendor approved by local authorities. Regular inspections and audits have to be conducted also in timely manner to verify and trace the authenticity of parts. Airlines have to work closely with local authorities and follow the acceptance procedure of the parts in accordance with aviation authority, such as FAA, EASA, Hong Kong CAD, CAAM, and CAAS. Engineers, technicians, store inspectors, and supply chain personnel have to go through the training and awareness of bogus parts and identification of them. Implementation of the training will cost approximately based on the number of employee, and then is as per the ISO 9100 training that is cost about 6,000 US dollar for this for the cost for the company which have a good quality system in place. Okay, next quiz is today I'd like to discuss about this FOD left out from aircraft maintenance activity by engineers and technicians such as materials and small parts and tools which can cause aircraft system failure, structure damage, and engine failure, impacting the safety of the aircraft, flight crews, and passengers. They already have reported accidents such as torch light left in the landing gear mechanism, preventing the pilot from retracting the gear, and that aircraft air turned back to the airport and causing inefficient operation and safety issues. A pair of cutting pliers was left in the right body gear lockup mechanism during maintenance, and due to that FOD, Boeing 747 aircraft failed to retract. Therefore, tools left unattended can cause damage to aircraft, risk to safety, and operational disruption, financial impact, as well as reputation damage to the airlines for their safety and reliability. The level of risk. The tools used by engineering team can be left behind if there is no proper guidance to keep their tools. The level of severity can be fatal, rating 4, and the rating of likelihood will be possible, rating 4, since maintenance activities are carried out every day on the aircraft and there will be high chance for tools to be left unattended. The relative risk level will be 16, which fall under high category. In order to talk about all these mitigation measures of FOD to mitigate this to prevent these accidents, two control procedures shall be implemented, ensuring all tools are accounted for every after maintenance activity carried out on aircraft. By using of two control boards, toolkits, and shadow boards were designated placed to remind the user if tools are missing from their safekeeping area. Engraving tool can be implemented for personal tools, and unique tools can be kept separately based on the ADA chapter as well. The person in charge of tool store shall keep tracking usage of tools from the tool store and raise red flag when the tools are not returned back to the store at the end of the dedicated working shift hours. Training and awareness programs shall be conducted in timely manner to all the personnel involved in using tools and managing tools on the importance of the potential risks associated with FOD tools. Advanced technology such as RFID, radio frequency identification, can be implemented to track all the tools record from store and its location to ensure no tool left behind at the aircraft and engines. The reporting and investigation shall be made if there are any incidents of lost tools in order to identify the root cause and also prevent from happening again. The exact cost can be variable depending on the specific safety measure to be implemented.
Okay, so this is where aircraft fueling process take places. This is the aircraft wing, as you can see, and the fuel tank is located inside the wing. This is the fuel vent. It is highly consideration to take off the fuel cap very accurately. And this is where the aircraft fuel are located. Aviation gas jet A1. And locking it is very highly crucial to take the necessary action for safety precaution. And lock has to be lockable. Hello, I will talk about fueling safety precaution for aircraft. So during aircraft refueling, it is crucial the safety consideration take place as this action is involved with many risks associated with aircraft fueling. Aircraft fueling not only to the aircraft but also to the personnel involved and the surrounding and the environment. This risk has to be considerably taken into action and avoid it as soon as possible. So in aircraft fueling, the fueling takes place here on top of the wing. This is where usually the fuel vent is located because fuel tank is located beneath the wing. In aircraft fueling process, the risks around include fire, explosion, fuel contamination, human error, equipment malfunction, fuel spill or leakage from the fuel vent, and also overfilling. Usually, aircraft fueling service provider, those are people who are trained to refuel the aircraft. They are trained professionally with high equipment and suit, but accidents do happen because of negligence. So it is vulnerable that this risk and safety precaution take into action. So it is the duty of the fueling service to be competent and professional during the fueling process and take the necessary safety precaution. For that, ensuring the necessary safety step taken during fueling is a critical aspect of aviation operation. to prevent accident, fire, and other hazards associated with aircraft fueling from spreading around the environment. So, the likelihood rating of incident involved during fueling processing is level 4, which is possible as it has happened before on multiple occasions. This is due to the fact that a safety precaution does not take into action. And this safety hazard can happen again if not taken into consideration, as aircraft fueling has a high risk associated with it. Moreover, the severity rating for hazard associated with aircraft fueling is level 5, catastrophic, as aviation fuel is highly flammable and have the potential to cause extreme damage if not handled carefully or managed properly. With this, the risk level is 4 possible times 5 catastrophic is 20 within the red band or high risk in the risk level chart. Okay, for method to reduce the risk associated with fueling safety precaution, so as aircraft fueling involves several risks that need to be carefully managed to ensure the safety of both the personnel and the aircraft, methods have been developed on how to reduce this risk, which is based on hierarchy of hazard control. Through this hierarchy of hazard control, the personnel protective equipment component, which is the PPE, the individual involved with aircraft refueling has to be protected from the risk. This could include providing a flame-resistant clothing and safety gear to the personnel. The purpose of this is to protect the workers or the personnel from the risk of getting fire or ignition during the refueling process. For instance, if the individual are wearing a headgear, goggle and a jacket, they can protect themselves from potential splashes, spill, debris, and guard the head against falling objects or head injuries. Moreover, using personal gas detector worn by individual that include a real-time alerting, it has the purpose to monitor the air surrounding the fueling process for presence of flammable gases or other hazardous substance which could lead to serious health effect. This equipment will alert the individuals of the hazard involved, and the personnel will take the appropriate action necessary to avoid the risk involved. Through this method, an estimated cost is based on various factors such as type of PPE used, the quality and brand, quantity, frequency use of the equipment, fueling service with the respective aviation fueling company.
Hello everyone, my name is Syed Asad. So I'm going to be speaking about the duplicate inspection, aka independent inspection. So this independent or duplicate inspection is a practice that's been carried out by many MROs or many airlines when it comes to engineering side. So to put it in simpler words, this practice, it's being carried out as a fail-safe method. It's control for critical maintenance tasks. Let me give an example. For example, an engineer, he or she is working in a system in aircraft on similar systems of the same aircraft. For example, me, let's say I'm working in one system, and let's say I had messed up something. I work on another system of the same aircraft, and I did the same mistake there. So in flight, this could cause redundancy issue. Because both the system is messed up at this point. So in that case, this duplicate inspection is carried out. So it's more powerful towards the paperwork when signing off the aircraft. So this duplicate inspection is mainly carried out in critical systems of aircraft. So I'm referring to the company's RSQCM or the Quality Control Manual, Repair Station Manual. So this duplicate inspection should be carried out in control systems like flight controls, engine, propeller, when it comes to installation, rigging or adjustments and stuff. Okay, so let me give you a live example for the use of this duplicate inspection. For example, here I am changing this fuel and oil lubrication hoses. So I just changed it. This is the old one. So I installed already. Now I did work on this engine, and there is another engine for this aircraft, and I changed over there as well, the same hose. So let's say if I connected the lines in some other, instead of connecting the fuel line to fuel line where it's supposed to go, instead I connect to an oil line, it could cause an incredible mess. So in that case, after the work is done, the inspection has to be done. So since I'm working on multiple engine of the same system, this duplicate inspection is a task carried out at the end of the maintenance task. So I'll change the hose here, change the hose there, and there'll be a special form for the duplicate inspection. So this special form will be done during the planning itself by the planning executive, saying that there is this repetitive inspection required. So in that case, after the main work task is signed off, I have to sign off on top of that for this duplicate inspection, saying I double checked that this critical task is carried out perfectly on multiple system. And not only me, a second engineer has to look into it. Usually one engineer is enough to sign off, but since it's a critical task, 2 engineers are required.
Okay, the engineering department should perform its duty and responsibilities well because slight technical error and damage a system and endanger all airplane passengers. This includes the oxygen system in the airplane. These things that are often done by the engineering department and are considered trivial but have a big impact in the event of any problem, including improper storage of goods. In addition, the handling procedure by the staff of duty also play an important role because of staff trained in handling oxygen cylinder can avoid any damage and leakage. Okay, inspections and maintenance of the oxygen system that does not follow the correct procedure is the main cause of any damage or leakage to the tank that has not been properly maintained for a long time, or the cause of leakage. Okay, the staff who are in charge of ensuring the safety of the goods do not perform their duties well and assume that the system is good. This gives a very high risk, and in the event of any leakage during the MRO process. Okay, that's all for the risk of oxygen safety implications. Okay, for now I will explain regarding the solution of risks that I have mentioned before in terms of oxygen precaution. Okay, there are several measures to reduce the risk of danger that will occur involving the implementation of a combination of measures to prevent accident from occurring in the hangar during the conversion or maintenance process, including provide comprehensive training, follow the SOP, and also recurrent the training for the staff also. Okay, first of all, about the providing comprehensive training to all personnel involved, the person who are working in the hangar. This includes staff who are directly or indirectly involved in the handling of goods, storage, and also the person who are in charge in storing the compartment, anything, and so on. Okay, about follow the standard operating procedure, or we call it SOP. We need everyone who are working in the hangar follow the SOP, like what my friend mentioned before, wearing the PPE, make sure everything follow the rules, make sure everything doing their job properly, smoothly, and so on. Okay, and recurrent training for staff with the strength understanding in their job scope. Make sure they know well about what they need.
Okay, in conclusion, to security and safety are essential to the aviation sector's operation. By giving these factors top importance, the aviation sector not only complies with regulation but also guarantees the safety, trust, and well being of everyone associated with or impacted by air travel. Maintaining the greatest levels of safety and security in aviation is made possible by ongoing developments in technology, consistent improvements, as well as dedication to the best practice. Thank you very much.